average speed, root mean square speed, and most probable speed. The distribution of molecular speeds, Maxwell speed distribution law. This is Maxwell speed distribution law. PV equal to 4 pi m, the molar mass, over 2 pi RT to the 3 over 2 V square E minus m V square 2 pi 2 RT, more or less like this one, okay? This is called the product PV times dV. Remember, you have a dV, which is a dimensionless quantity, is the fraction of molecule whose speed lies in the range V to V plus dV. It's fixed meaning. PV dV is the fraction of molecule whose speed lies in the range V to V plus dV. This is probability, okay? So this is probability for V and plus dV. And we do the sigma, or the integration from V initial V1 to V2. What this mean? This mean is the fraction of molecules with the speed in an interval of V1 to V2. Or we take V1 equal to 0, V2 equal to infinity. This is, you cover all kind of speed velocities, vertical. So it should be 1, 100%, okay, 100%, right? Maxwell, great physicist. Okay, we will learn something, theory from him. Okay. Now let's go back to this one. Okay. We plot the curve, and this is a p, and this is speed. Okay, the speed, and we find this one is area. This area called the pdv. The dv in here is a dv. This the area map is the percentage fraction of the molecule within this range. And we know that all the area under this curve is 1 because the percentage is 100% is 1, okay? And we will have 3 speeds. This is called most probable speed, VP, because it's probability is the highest. And this one is the average velocity, all the velocity, average velocity, all the element. And this is called root mean square, as we mentioned before, okay? And the total integration is 100% equal to 1. You take it from 1 velocity to 1, 0 to infinity, 0 to infinity. Whatever curve, you always have some molecule with very high speed, okay? Now you see, this is also a function of t, all right? At different t, we have this different distribution of speed. With high t, so 80 degree, 80k, 300k, the high t, you have more molecule with high speed. This is high speed, okay? Average speed, root mean square speed, and most probable speed. We calculate from this one. We know the percentage, okay? So the average percentage is the V multiplied by its probability. This is the percentage, and the sigma, okay? The sigma. And we do put the V inside, we do the integration. This integration is not very hard. It's not a big one, not a very big one. So it's very easy when to do it, okay? We can find it's square root ART over pi m. This is called average speed. Root mean square speed, by definition, okay, is this average, okay? We do the average V square, we put the V square probability, sigma, the integration from 0 to infinity. And this one, we get equal to 3RT over m. And the root mean square speed is square root, is square root, this one. So it's square root 3RT over m. Finally, have most probably speed. What do? We take dP dV equal to 0. You can find maximum minimum. In this case, we find the V is equal to square root 2RT over M. This is 3. You remember the answer. You don't have to do the calculation. Okay? Now we look this one. Look at ring. The speed distribution of water molecule in, say, a pond at the summertime temperature can be represented by curves similar to this above curve. Most molecules do not have enough energy to escape from the water surface. However, some small numbers, very fast molecules with speed far out in the tail, okay, they can do so. They can escape from the surface of energy. Okay. This is a water molecule that evaporates, make the clouds and the rain a possibility. As the fast water molecules leave the surface, okay, carrying energy with them, the temperature of the remaining water is maintained by the heat transfer from the surroundings to have. At the same temperature, you have always, so the collision, you have always very few molecules with high speed. So it will continue to evaporate too. Sunshine. Let this distributed curve above figure now refer to protons in the core of the sun. That's the proton in the core sun. The sun's energy is supplied by a nuclear fusion process that starts with the merging of two protons. But the protons repel each other because they are electric charges. And the protons at average speed do not have enough kinetic energy to overcome the repulsion and get so close enough to merge, so get the nuclear fusion. But you always have very fast proton with speed in the tail of the distribution curve can do so. So the sun, in sun, you have always few very fast proton. They can close together and cause the nuclear fusion and give it the heat. Sample. A container is filled with oxygen gas maintained at room temperature 300 K. What fraction of the molecule have speed in the internal 599 to 6.0 meter per second? The molar mass M of oxygen is 0.0320 kilogram per mole. Now, we use this one. We do it. Okay? We do this one. Okay? We want to find this V. Okay? Percentage. What fraction of mole? You want to find the percentage. What we do is, let me set this, the red one, M over 2 pi RT to the 3 over 2 power 8. And this mv squared over 2 RT over B. Now, dV in this case is 2 meters per second. It's given. Okay, it's given. And V is around 600 because 599 to 6.0 V is around 60. So we put this number into the Maxwell equation. We need A and B. We put A is the M is molar for oxygen 0.03 kilogram. This R is 8.31. T is 300. FC2. You get A. Also need to get B. B is minus mv squared over C. We put the V is around 600. Okay. T is 300. M is 0.32. Look at the B. So we put this one. PV dV equals 4 pi A V squared e to the minus dV. Then we put everything now is about 2.62 times 10 to the minus 3. That's about 0.00262%. Very few. Okay? Sample. The molar mass M of oxygen is 0.0320 kilogram per mole. Question A. What is the average speed? V, average oxygen gas, molecule at T 300K. This is very simple, straightforward. We put this one, you got it square root from 0 to infinity. Okay, this is average. Okay, this is average speed. This is equal to 8 RAT. We have calculators. We put them inside. We have M, we have a T. Very simple. Okay, that is straightforward. About 445 meters per second. This is the speed of oxygen at the room temperature. Okay. Question B. What is the road mean square speed? V, road mean S at 300K. Then we see we have a formula too. This is a square average and a square root. Okay. So this one equal to square root 3 RT over M. We put a number inside. Look at this one. This one is bigger than average, right? And we have finally we have probable speed. Okay, we put a number inside. Okay, this is 2 RT over T. We get about 393. It's smaller than this one.